Good Tuesday to you, everybody. Incom 702. Welcome to the beginning of week. Boom. 6. How's everybody doing? How you hanging in there? Lots going on this time of the semester. Hustling through or towards midterms. We don't have a midterm in here, so don't panic. Maybe in other classes. Lab 6 and the quiz for Lab 6 is open and available, so make sure that you get in and do that. And, I don't know what it's like in your part of the country, but it's just been downright gloomy here, as you can see from the lighting or lack thereof in my office. So, cheers. All right, let's get started. Don't know what that's about and don't care to find out. So you should have settled into your research topic. And if you haven't by now, please reach out to me. And, if you have questions, you're not quite sure how you're going to do this, now is the time, because we're coming up to the end of February. It's happy Valentine's Day. Sorry, I forget. And so, we get through, we've got like about less than 2 weeks of February. Then we're going to get into March. And then that sucker's due April 23rd. So you want to have March to write it up, design your study, even just a pilot study, get your survey instrument out there, get your data in, and then start running your statistical analyses, your tests. And then you want to use that time in April, excuse me, to write everything up and clean everything up. Okay, so if you don't have that and you're, you haven't figured it out, or maybe you're feeling lost, please email me and we will get you straightened out. Okay, let's take a look at the questions from last week, week 5, a review of forum number 5. We're looking closely at analysis of variance of various kinds. All right, and what they are and what they're for and what do we do with them. So question number 1, when should analysis of variance, that is ANOVA, be used as a statistical method? And when should you use analysis of covariance, ANCOVA? Okay, so you remember those two. And again, you've heard me say this before, but I shall say it again. These terms, ANOVA, ANCOVA, t-test, all these things, you got to memorize them. You got to get them down cold. They'll be on the test. They form the vocabulary of quantitative research. Reading through your responses, I appreciate that you dig into the specificity of the terminology of the definitions. There's a mouthful for you. But I have to be honest with you, in some instances and from some responses that I read, I'm not entirely convinced that the writer knows exactly what he or she is explaining. Okay? And this is not a criticism or critique. It's a concern. Don't just go Googling away and then copying and pasting a definition. And in some answers that have been given, I can tell that's what you did. Understand it. You have to understand it. Okay? That's the point of the discussion board and the exercise. And again, I want to make this very clear. This, my mentioning this is not a criticism of what you're doing. It's a concern for what you get, because what you need to get is an understanding of this. And I know there's a lot being thrown at you. Okay. And it's sort of like, but you just have to keep up, create flashcards, type it out. It helps when we write things out for memory and recall, whatever it takes. Okay, back to question number 1. When should analysis of variance ANOVA used to be used in statistical method? When should you use an ANCOVA? Okay, so first and foremost, when you get something like this and you might be scratching your head going, yeah, geez, I don't know. Make sure that you have an operational understanding of the two terms. You know what they are. So remember that an ANOVA is used when you want to compare the variance of the means, okay, across the means of different groups, more than 2, because you could compare the means of variance of just two, and you do that in an ANOVA and you do that in a t-test, and you basically get the same thing. You're basically doing the same thing. A t-test is not good for comparing more than two, like if you have three. And basically, let's say, where's my little sticky pad here? Okay, so let's say that you had some data set, and you have an X and a Y axis like this. Okay, and let's say on this side we just say money out, and on the y-axis, and on the x-axis we say hours in. So how much time working, whatever, results in what amount of money. And you have three groups doing the same thing, and you want to see what they get. And then so if you plot them all out, you get like this. And I'm going to show you this picture in just a second. This would be like group one. And then you get group two that kind of goes like this. Okay. And then you get group three that goes like this. So we'll go 1, 2, 3. I promise you I'm going to show you this. Okay, because these are my magic sticky pads. Karl Rove has his whiteboard. I have sticky pads. Okay, so here we have the y-axis, the amount of money out, for the x-axis, hours in. And we look at three groups, 1, 2, 3. And if we plot them on a graph, we have a data set that looks something like that. And then each of them with a means, right down the middle, group 1, 2, and 3. Okay. So let's say that we want to compare the variance in those means to see if they're really different, because just looking at them on the graph, group 1, the amount of money they make is way up here in this really short amount of time period. Okay. Then we look at group 2, the amount of money is way down here, but over this time period. But if we average it out, let's suppose that the amount of money because of the duration for group 2 is roughly equivalent to the amount of money because of the short duration from group 1. So just looking at the data wouldn't necessarily tell us if there's a difference in the mean. So we run an ANOVA, right? And it's good for that. Okay. And ANCOVA, ANCOVA, on the other hand, is used to test the means, the effects of categorical variables on dependent variables. Now, when you read fields, they'll say predictor variables on outcome variables. So just a little bit different language when you get across the ocean, but you can figure that out. Okay. And I think, Amanda, I'll take your answer here, because you started with that. You said ANCOVA is used to test the main effects of categorical variables on a continuous dependent variable. But here's the important part you need to remember and to add in when you're talking about ANCOVA. And when there's a third variable involved, and this variable is called a covariant, so it's an additional variable. All right. So when there's a third variable involved that can be measured but not controlled, and has a definite effect on the outcome of the variable that is the one that you're trying to study. So let's say, for instance, you're looking at, I'll give you an example, a real life example. Okay. Let's say you're looking at the incidence of severe COVID outcomes. All right. So COVID is your independent variable. Severe outcome is your dependent variable. Okay. But let's say amongst the people that you're looking at that you have some people who have been lifelong smokers, and as a result, no, this isn't the only reason, but as a result of heavy tobacco use, they have COPD, chronic obstructive pulmonary disorder, right? That's now a covariant. Okay. Now you can measure the COPD, but there's no, you can't necessarily control for it because to say this person's COPD is not as bad as this one, as this one. So you can't like take it out of the equation. That's what control means. It doesn't mean control like as in not ensure that they don't have COPD. It means you can nullify it in the study, and you can't do it, but you can measure it. All right, so you need to take its effect into account. So you find some measure, some means by which some number that you can quantify. And for COPD specifically, they'll often measure the severity of COPD by breath strength. They have someone blow into a tube, and then the tube attaches to a little plastic device in which there's a little ball that their breath raises up a certain height. Oh, they ask them to blow over a specified period of time, and can they, how high can they raise the ball? Because this measures oxygen output and lack thereof, restriction thereof. All right, that's one of the simple tests. There are some others that are a little more involved that involve CO2 saturation, or excuse me, CO2 saturation, O2 saturation within the body, and so on and so forth. Okay, back to you, Amanda. So, ANOVA is used, or ANCOVA is used to test main effects, categorical variables, and continuous dependent variable. And then remember, when a third variable that is a covariance involved, it can be measured but not controlled. That is, you can't take it out across the groups. Okay, and it has an effect on the dependent variable. And then Amanda goes on to say ANCOVA is used for analyzing quasi-experimental studies. This type of study is where the treatment of the group is not randomly assigned, and the researcher wants to statistically equate groups. Statistically equate groups. I think you mean of one or more. You have on one or more, of one or more variables that may differ across groups. Overall covariance are controlled variables in this case. Okay, controlled in the sense that you can, nullify them. Okay. Does everybody understand that? I hope I didn't make a mess of it for you. The difference between ANOVA and ANCOVA. If you don't, please email me. All right. Question number 2. Why would you want to study interaction effects using ANOVA? Dustin, good answer here. Interaction effects, the combination of effects of two or more predictor variables on an outcome variable, or as we would say, independent variables on a dependent variable. It can be used to gauge moderation. This is from Fields. From our readings, we understand that ANOVA is used to compare and contrast the means of two or more populations. Yeah, or the means, okay, the means of the dependent and independent variable effects across two or more populations, okay? And you know that you also found an article entitled Interaction Effects in ANOVAs that discusses this relationship as well, that states interaction effects represents the combination effect of factors on the dependent variable. When an interaction effect is present, the impact of one factor depends on the level of other factors. Parts of the power of the ANOVA is the ability to estimate and test interaction effects. It rarely happens in life that there is a one single cause. There's a one single independent variable that causes a dependent variable. Now, it often happens in statistics that you want to isolate that one single independent variable and see its effect on the dependent variable. Okay, so you want to know about interactive effects. And you want to be able to identify these additional variables, and if you can, control, that is, take them out. This is frequently done in medical studies. They'll control for age, they'll control for weight. So back to smoking, they'll say, and they'll give the number in averages that the risk of smoking across the population, the risk for cancer, lung cancer, because of smoking across the population is blankety blank. Or smoking, in certain number, a pack of cigarettes a day raises your chances for cancer, insert the number because I don't know what it is, across the population, controlled for age. All right. So now, this doesn't mean that if you're 5 years old and you smoke a pack of cigarettes, your risk for cancer is exactly the same if you smoke a pack of cigarettes a day at 50, or if you smoked a pack of cigarettes a day from when you were 5 to when you were 50, or you just started when you're 50, is exactly the same. They're saying across the whole population, this is what it is, taking out the factor of age. All right. So when you want to do that, you want to be able to determine interactive effects and control for them. Okay. Good answer, Destin. Okay. Question number 3. What is the F ratio and why is it important? All right, Elaine, the F ratio answers the question, is the variability between groups large enough in comparison with the variability within groups to justify the inference that the means of the population from which the different groups were sampled are not all the same? All right, now, there's a good answer, Elaine, but make sure that, everybody, you understand what this means. All right, to break this out, and you see this, this is one of the numbers that you report when you write up your results. All right. Say analysis of variance. Okay, so remember that the F ratio is used to determine whether the variance in two independent samples are equal. All right. So let's say, you're using a simple t-test, or you're using an ANOVA, and you're comparing the means between two groups in, remember back to, say, labs 1 and 2. Women using social media and strengthening their faith, that's one group. Men using social media and strengthening their faith, okay? 2 different groups, same independent variable, same dependent variable, using social media, strengthening their faith. Okay, what's the variance between these 2 independent samples? Is there any difference? Are they equal? If the ratio is not statistically significant, because you're going to get some difference. I mean, maybe you sampled more men than women, okay, because you didn't get an absolute even number. You say in your study, we didn't get the very same number of women as men. And maybe, within the women sample, there were a couple of social media hounds, and they were always on social media doing everything. And in their mind, when they answered the survey, they go, oh, yes, every time I'm on TikTok, that strengthens my faith. I mean, does it really? I don't know. I'm not criticizing. I'm saying that's just how they answered. And they answered, absolutely. And they skewed the numbers in the female group. All right, so you're going to get these difference in variance, okay? If the ratio is not statistically significant, okay, you can assume that there's homogeneity of variance, and you can employ a standard t-test of the means. If the F ratio is significant, okay, and the number that you're looking for is the closer the number is to the number 1, this tells you that there's really no difference. The further away, the larger the F ratio number is from 1. This means that there's a larger variation in the means between the 2 groups, more than you would expect to see by chance, within that 5% wiggly room. So some other factor is driving the difference other than just random chance, meaning women use it more to strengthen their faith than men, or men use it more to strengthen their faith, as do women. Okay? Does everybody understand that? All right. Question number 4. What's the difference between main effects and simple effects when you conduct an analysis of variance? Okay. Main effect is the unique effect of a predictor variable on an outcome variable. And remember, that's Field, who's a very funny guy, but he's very British. And if you turn that into American English, you would say the unique effect of an independent variable on the outcome on a dependent variable. Okay, we're just switching out the terms. While the simple main effects are the difference among particular cell means within the design. Okay, that one I think is pretty straightforward. Essentially, this is Cassiopeia. Good answer here, Cassiopeia. Essentially, when using ANOVA, the main effect is the significance of an independent variable and a dependent variable. Okay, so you straighten out the language here. If there is no main effect, meaning the results are statistically insignificant, then there might still be simple main effects between 2 independent variables. Okay, very well said. All right, everybody. Short video for today, about 20 minutes. You got to write these terms down. You got to internalize them. Just learn them. Live them, love them, and then you're going to do fine. Hey, look at that. And the sun came out too. All right, everybody. Have a blessed week. If you have any questions or, anything, whether it's the labs or the paper or something, reach out to us. Now, Dr. Brown is going to be gone by the end of this week and out of pocket for a bit. So direct your questions this way, and I'm here to help you out. Okay. Think about you often. I pray for you just as often. Have a blessed week. See you on Blackboard. Bye-bye.